Good afternoon, TechNation. Welcome to another phenomenal webinar Wednesday. Not only is TechNation the leading publication for the HTM industry, we also offer the hottest conference for the biomed clinical engineering field, the MD Expo, in Dallas this April. Check out more information in the 26 continued education classes at mdexposhow.com. Okay, as part of giving back to our TechNation community, let's kick off today's webinar Wednesday by giving away one of our stylish TechNation pullovers. Using the questions feature on the right-hand side, who can tell us where the very first MD Expo was held back in 2001? As you're using the question feature, I want to go ahead and tell you that while you're answering, I want to remind you that the webinar is eligible for 0.1 CE credits from the ACI. To obtain your certificate of attendance, you must complete the post-webinar survey, which will appear immediately on your computer screen at the end of today's call. If you did not receive the survey, you can email us at webinar@mdpublishing.com. And we're still getting some answers coming in, and we don't have a, oh, there we go. Greg Johnson answered it correctly, because I think he was there in Stone Mountain, Georgia. Way to go, Greg. We're going to send you one of our beautiful TechNation pullovers. Great job. Okay, TechNation would like to thank our sponsor today, Fluke Biomedical. Fluke Biomedical is the premier global provider of test and measurement equipment and services to the healthcare industry. You can visit www.flukebiomedical.com to learn about their products, services, and training. Our presenter today is Ashton Solecki, the product marketing manager of the Neonatal Test product line, including incubator, radiant warmer, and phototherapy testers for Fluke Biomedical. Ashton, you can begin whenever you're ready.
Great. Thanks, John. Hello, everybody, and welcome to this educational webinar. Again, my name's Ashton, and I'm going to lead today's discussion on best practices for infant incubator testing to help you ensure proper performance and safety of these medical devices, and ultimately to help you protect the safety of your smallest patients. So today we're going to start off with just a bit of background information and understanding the basics of incubators and how they work. We'll then talk about the importance of testing and global testing standards. But the majority of our time, we'll talk about some best practices for incubator testing, both very high level and then some quite detailed. And then finally, we'll wrap it up and tie everything together in a review. And then, as John said, we'll end the webinar with questions from the audience. So we've come to our first poll question to kick it off today.
All right, Ashton, I'm going to launch the poll for the attendees. They should now be able to see the question. Were you or do you know someone who has been in an infant incubator? The options are yes or no. While the attendees are busy answering this question, I do want to remind everyone we're taking questions at any time during the presentation. We'll wrap up with the Q&A. Feel welcome to submit your questions through the question feature on your dashboard. We will hold all questions until the end of Ashton's presentation today. Looks like we have over 75% of the audience has voted, so I'll go ahead and share the results with everyone. 63% of our audience, Ashton, have answered yes, with 37 saying no.
Great, thank you. So I want to start off by, getting an idea of the patients that are using these incubators. So according to the World Health Organization, more than 130 million babies are born worldwide each year. And, while welcoming new life into the world is a wonderful and awe-inspiring event, sometimes things don't always go as planned. So about 1 in 9 babies are born premature, and many more of them are born with illnesses or are injured due to complications during birth. Premature births and complications are relatively common, and even according to the poll, 63% of you listening, myself included, have either been in an incubator or know someone or a loved one who has been in one. So these small patients are especially vulnerable for the first several days and even months of life. So this is when the use of infant incubators becomes absolutely essential. So these premature, injured, or ill infants are placed into an incubator, which is vitally important to the well-being and care of these babies. So an infant incubator is, a fully enclosed, kind of box-like structure that carefully controls its environment to protect the infants during their earliest stages of life when they're the most vulnerable. The FDA classifies incubators as Class 2 medical devices, meaning they are higher risk devices than Class 1 and require greater regulatory controls to provide reasonable assurance of the device's safety and effectiveness. So by modulating the temperature, humidity, airflow, sound, and often oxygen levels, incubators seek to replicate the safe haven of a mother's womb as much as possible and create a safe environment for these premature and very ill babies to grow, heal, and develop in. The incubator may include an AC-powered heater, a water container to add humidity, a motorized fan to circulate the warm and humid air throughout the cabin, a control valve through which oxygen might be added, and then a servo control to help regulate air temperature. So it's a temperature sensing thermistor is actually taped to the infant's abdomen. There's hand access ports with doors that limit the introduction of cooler air while the infant, if it needs to be handled, and the hood or the side panel can be opened to gain greater access to the infant. So the heat circulated in the cabin is then absorbed into the baby's body by blood convection and tissue conduction, so ideally keeping both the baby's skin and core temperature maintained by just minor variations. And then just a side note is that the mattress will often double as a weighing scale because the process of weighing these fragile and sick little infants is often just a trying and time-consuming task for the nurses and can be detrimental to the patients too. So we've come up on our second poll question.
All right, the attendees will be able to see our next poll question, which is the term STC, steady temperature conditions, for an infant incubator refers to, and please select one of these options: the moment an incubator hits the temperature set point, when an incubator stays within 1 degree Celsius of its set point for an hour, or I'm not sure. Ashton, the attendees are busy voting right now, and it looks like we have a clear winner. I will share the results with everyone. 81% of the attendees say that it is when an incubator stays within 1 degree Celsius of a set point for an hour.
Great, thanks, Jamie. So good job to the 81% because STC, the steady temperature condition, is the condition that's achieved after the incubator does remain within the 1 degree Celsius of the set point for an hour. So here's a visual of what's going on. When an incubator is first turned on and a temperature is set, say, at 36 degrees Celsius, temperature mapped over time looks like this with temperature on the y-axis and then time continuing there on the x-axis. So when we first turn on the incubator for a test, it should be at room temperature or ambient temperature. And the time that it takes for the incubator to warm up to 11 degrees Celsius above whatever your starting temperature is called the warm-up time. So say my ambient temperature is 20 degrees Celsius. However long it will take my incubator to get to 31 degrees Celsius is then considered my warm-up time. An incubator's warm-up time it's usually set in the manufacturer's manual, and this is very important to know, and we'll touch on this again a little bit later on, but the warm-up time must be measured to make sure that it's within about 20% of the time that's listed in the manufacturer's manual, and here's why. So when a baby is being admitted to an incubator, the nurses or clinical staff will turn on the incubator and want to have it warmed up and ready for the infant to be placed inside. So if the manufacturer's manual states that it takes 25 minutes to warm up, so indeed the nurses, the staff, and the small little infant that's going inside, they're going to expect that the incubator is going to be warmed up. So if the incubator isn't warmed up in this time, the consequences could just be completely dangerous and even fatal to the newborn's health. So after the incubator goes through its warm-up time and reaches its set point, the temperature will then overshoot and then undershoot and then oscillate in kind of small temperature variations, resulting in an average temperature of the incubator. So when we think about the acceptable ranges that an incubator overshoots and then undershoots, and we have to remember just how fragile that the infants are to even minute changes in temperature. So according to the standards, and what I'm talking about with the standards is the IEC 60601 2-19 standard for incubator testing, where this diagram was actually adapted from. The overshoot shouldn't be more than 2 degrees Celsius. I apologize that the arrow on the screen is covering that up. But again, the overshoot shouldn't be more than 2 degrees Celsius. And that may not seem like a lot to us, but remember how sensitive and fragile these premature and sick infants are. So again, no more than 2 degrees from the set temperature as an overshoot is what's acceptable. So once the incubator has gone through, these minor temperature oscillations with the temperature varying by no more than 1 degree for an hour, the incubator has then reached that condition called STC, the steady temperature condition. Once the incubator achieves STC, its most important function then is to keep a uniform environment in all parts of the chamber. So temperature should be the same in all parts of the cabinet. Humidity and oxygen should be at appropriate levels and stay constant. The airflow above the mattress, right above the mattress, shouldn't exceed more than 0.35 meters per second. And it should stay relatively constant to there to really help circulate that warm temperature, the humidity and the oxygen, to ensure that all parameters are consistent throughout the cabinet. Incubators also help to minimize sound and vibrations. So below 60 decibels adjusted is what's considered acceptable for these infants' tiny and fragile ears. And, alarms will be both visual and audible too, so loud enough to, of course, alert attention, but low enough as to not harm the baby. So why is testing these incubators important? Well, clearly we've been mentioning how fragile these newborn, premature, and sick infants are, but I think that we say that so often it's become, so just generally true that we actually start to lose the meaning and the compassion behind that statement. So what happens when a parameter isn't in the acceptable range it should be? What happens when temperature is out of whack, even in just a corner of the mattress? What happens when humidity or sound is too high or too low? So just to give you a few examples, temperature, for example. A premature baby can't modulate its own temperature. So if the infant is too cold, it can result in hypothermia. So that means the baby is shivering, its glycogen stores are depleting, and it's using all of its energy that it should be using on growing, healing, and developing on trying to stay warm. Apnea is also a common side effect, meaning that the infant will stop breathing in its sleep, and that leads to oxygen deprivation. And oxygen deprivation can result in brain damage, and it doesn't take very long to do so. So on the other side of things, temperature-wise, is hyperthermia. So that's when the baby is too hot. Dehydration and cerebral or brain damage can happen when the baby is on the low end of hyperthermia, but the severe cases of hyperthermia can even result in heat stroke and sometimes even death. So loud noises, both from the operation of the incubator and even background noises, can clearly lead to ear damage and even intracranial pressure. Humidity is extremely important for the respiratory care of the infant. So humid air is what helps the baby to breathe and for the oxygen to be exchanged into the blood and carbon dioxide out of the blood at the very cellular level. So when a higher humidity is set in the incubator along with a constant heat, the infant heat and water loss are reduced, which is very desirable things. As for airflow, we talked about this, and airflow helps circulate the warm air throughout the cabin, but high air velocities, so anything above that 0.35 meters per second that we talked about, that can often lead to evaporative water and heat loss for the patient. And then finally, oxygen, a low oxygen concentration can cause brain damage, and a high oxygen concentration may cause premature retinopathy, and that leads to permanent eye and vision damage and sometimes even blindness. So these are just a few examples, and all of these can result in just dire consequences for the patient. I'm talking, lifelong disabilities and even death. So testing incubators completely and properly to make sure that they're performing the way that they should be and that the environmental parameters are in a safe range just becomes essential in helping protect the safety of the patient. So now that I tugged on your heartstrings enough, let's consider some other perspectives and reasons for why testing incubators and doing so thoroughly is very important. So shortening the time that a patient spends in an incubator is a desirable outcome for everybody involved. So not only is the cost of care for hospitals quite high, not only via the time, but also the energy that nurses and clinical staff use in pursuit of the well-being of the patient, that's immense and often overwhelming. And having a child in a neonatal unit is emotionally and financially draining for families too. So reducing the time that patients spend in an incubator is desirable for everybody. And if we can test incubators and help ensure that they are functioning the way they should be, we can help eliminate any time that's spent in that unit due to faulty performance of the incubator. So with how fragile these infants are, it becomes pretty obvious that testing all the parameters and testing them appropriately and according to the standards and/or the manufacturer's guidelines is absolutely critical. So the International Electrotechnical Commission, or the IEC as we better know them as, the IEC Standards, they reflect the best experience of the industry, of researchers, consumers, regulators worldwide. And what the standards do is they help establish a uniform and universal testing procedure for biomedical service design engineers to use, and they're critical in helping properly assess the safety of medical devices and thus ensuring patient safety. So for this reason, most of the local, national, and what I mean by local, national is by country standards, have been harmonized to the IEC standards, which are recognized as the international preferred practice. So the IEC 60601 2-19 standard recommends the basic safety and essential performance requirements specifically for infant incubator testing. So as it turns out, testing standards and regulations go hand in hand, especially when we consider more reasons as to why it's important to test and verify the performance of incubators. So who uses the standards, or should use the standards, and why? Well, first, OEMs. The FDA and ministries of health regulate the medical device manufacturing, the sale, and ongoing safety review within a country. They'll also approve incubator designs that can be sold in the USA or specific countries that are based on the data collected when following the prescribed tests in the IEC standards for incubators. So thus, many, if not most, manufacturers based their specifications and their testing procedures around the standards, and from them stems the manufacturer's service manual. So as we all know, a manufacturer's service manual will contain procedures specific to the maintenance and performance of the device, and they'll typically recommend an inspection frequency too. So while these testing workflows tend not to be quite as thorough as the standards, each manufacturer will apply the standard to the best testing for the design of their brand and model of infant incubator. So the manufacturer's service manual will give model-specific directions to test the incubator, such as the need to ensure that warning lights turn on when they should be. So if the temperature is too high, the alarm should sound, sort of thing. And who uses the manufacturer's service manuals? Well, independent service organizations and biomeds and hospitals. Local insurance and corporate requirements will also frequently conform and then require compliance with the standards. The Joint Commission, which is in the USA only, audits and accredits hospitals, including the biomed departments. The medical device testing accreditation is based on the hospital's medical device management plan, and testing is to be based on the manufacturer's recommendations unless other independent objective evidence shows alternative testing is effective. So all of these then circulate back to the standards, and why testing incubators to the standards is important. So now that we've reviewed the background, the basic functionality, and the reasons to test infant incubators in the first place, let's now discuss what some of the best practices are for testing these infant incubators. So first, be sure to always complete the performance inspection either per the standards and/or the manufacturer's procedure. So these will often include weekly or after each patient use sort of checks, quarterly checks, yearly preventative maintenance schedules, and then also replacing the battery usually every 2 years, and then calibrating the humidifier every 3 years. So if the service manual and the inspection procedure from the manufacturer is not available, it's still the responsibility of the medical facility to choose and standardize on a test procedure. So it's important that the infant incubator functionality be evaluated quantitatively by comparing it to the applicable medical device standard or the manufacturer's specifications. So if the manufacturer's specifications aren't known, again, those IEC 60601-219 standards are a great place to start and a more than reasonable substitute. So once the inspection criteria have been agreed, no changes should be made without a rationale statement describing why a change was required, what the change is, and then how this change was validated. As we've talked about throughout most of this webinar, an infant's first few days of life can be their most critical, which is why it's important to routinely test and verify the safety and performance of infant incubators and adopt a consistent inspection frequency. So check the manufacturer's service manual for the frequency recommendations. The FDA, along with most manufacturers, will recommend a minimum inspection frequency of once per year. If the service manual and the inspection procedure from the manufacturer are not available, the frequency of inspection must still be determined. So one method for determining how often a medical device should be tested is a risk-based method used by the University of Vermont, the biomedical engineering department there. And I'll show this on the next slide. But this risk-based method is described in the Medical Equipment Quality Assurance book, the Inspection Program and Development Procedures by J. Toby Clark. So on this slide is an example of a risk assessment. One column is done by the University of Vermont, and the other in red is the Fluke Biomedical column, just to show you an example of how this can be filled out. So a combined score of 13 or more is justification for semi-annual testing, so more than once a year. A combined score of 9 to 12 is justification for just annual testing, so once a year. and then a combined score of 8 or less is justification for less than annual testing. So this column was the one from University of Vermont, and this column in red is the one from Fluke Biomedical. You can see the differences highlighted, and the risk assessment from Fluke Biomedical differs just slightly from the University of Vermont in 2 main categories, the problem avoidance probability and incident history. So problem avoidance probability was rated a 5 from Fluke as opposed to a 2 because both regulatory and manufacturer guidelines recommend weekly, quarterly, and yearly preventative maintenance schedules. Incident history was rated a 2 instead of a 1 because incubator incidences could result in patient harm. If incidences wouldn't result in patient harm, then the score would be a 1. So the total score for Fluke Biomedical is a 12 instead of UV's score of 12. Indicating a semi-annual or twice per year testing for infant incubators. So whichever frequency you deem is most appropriate for your equipment, for your facility and patients, just be sure to have a written statement with your justification documented. So this statement of policy is going to come in handy during audits of your quality assurance program. Okay, and we've come up to our 3rd poll question of the webinar.
Great. The attendees are now able to see the question. When testing an incubator, how many places do you currently measure the temperature inside the incubator? Please select 1 or spot check, 2 to 4, 5 or more. While you're voting, I will tell and remind all the attendees, we have received some questions for our Q&A, but you still have time to get your question in. Again, we're going to hold all questions until Ashton's presentation is over. We'll address as many questions as we have time for. But it looks like the majority of the audience has voted. Let's go ahead and share these results, Ashton. And there we go. It's 60% have voted 2 to 4, 23% said 1, and 18% said 5.
Great, thank you. So the probe placement, and the reason why I placed this question there in this webinar is because the placement of probes when you're testing parameters, especially temperature and airflow, are common misunderstandings when testing and performing the preventative maintenance for infant incubators. So the sensors for all parameters, including temperature, humidity, the airflow, and the sound, should be 10 centimeters above the mattress, which is approximately the height of an infant when laying flat on the mattress of the incubator. Temperature, so what I mean by that is the air convection temperature and airflow should be measured in 5 locations inside the incubator. Capturing the temperature in just a single location isn't really acceptable. And if you think about it, it makes sense because an infant's torso and limbs may be stretched across more than just the very center of the mattress. And thus, we need to make sure that the environmental conditions are uniform across the entire chamber. Maintaining that infant's core and their skin temperature is absolutely critical. And as we think back to how an incubator functions, a motorized fan will circulate that heated air throughout the chamber of the incubator, and heat loss from the infant by convection is dependent upon the airspeed and the air temperature. So measuring the temperature and airflow of the incubator in each of them in more than one location is going to give a good insight into the actual performance of the medical device, ensuring the uniformity of environmental parameters, because remember that infants cannot self-thermoregulate their temperature. These premature babies cannot. So when a temperature is a little out of range, even in just one corner of the mattress, perhaps where the baby's leg is or arm, because that baby can't self-thermoregulate, that could lead to hypo or hyperthermia or other dire consequences that we touched on earlier. So if we were to divide the mattress into 4 equal quadrants, temperature and airflow probes would be placed in the very center of the mattress, which is point M on the diagram you see, and then also in the center of each quadrant, so points A, B, C, D on your screen right now. Finally, the pattern of airflow just slightly differs in every model of incubator. So it's important to be familiar with the direction of that airflow inside the model of incubator that you're testing and place the airflow probe properly to make sure you're getting an accurate measurement. You'll remember this diagram from the beginning of our webinar today, and it shows, remember, the warm-up time, the overshoot, and the oscillation to a steady temperature condition. The manufacturer's manuals will specify that warm-up time, and again, the testing should be carried out to ensure that the incubator is within the acceptable range of 20% of the warm-up time. So again, the temperature overshoot should be no more than 2 degrees above the set point. And remember that STC, the steady temperature condition, is achieved when the incubator temperature doesn't vary by more than 1 degree Celsius over a period of an hour. So simultaneously measuring each parameter, I apologize, it looks like it went off the screen a little bit, but simultaneously measuring each parameter during the warm-up time and after STC helps give us an insight into how the device is running as a whole and where problems might be occurring if the incubator isn't functioning properly. So keep in mind, though, that each time you open a porthole or a cabin door is opened, the STC is technically lost and must be achieved again. So it's important to do your testing all at once simultaneously if possible and not interrupt the test environment. So another very obvious best practice is to perform all the tests that are necessary to ensure the proper performance, right? So there's a complete list of tests and criteria that can be found in the IEC 60601-219 standard or the manufacturer's service manual. But here are the basics. So for temperature, we need to make sure that the incubator warms up time specified in the manufacturer's manual. We've got to make sure that the overshoot temperature doesn't exceed 2 degrees Celsius of that set point. Check all the surfaces that in a tight touch the infant, from the mattress or anything left inside, and make sure that they don't get too hot. So test to determine when the incubator's temperature stabilizes and then stays at that temperature setting for at least an hour, so STC. And then finally, verify the temperature is uniform and the same throughout the compartment. Make sure the accuracy of the temperature indicator and make sure the temperature control sets the temperature to the correct value. And finally, lastly, measure the skin temperature sensor with a calibrated heater assembly. So test to ensure the temperature control is the actual temperature sensed by the skin temperature probe. Because remember, the skin temperature probe is taped onto the skin of the baby, and that lets the incubator know what the infant's temperature is, and if it's too hot or too cold, the incubator will automatically change the temperature to adjust and hopefully help that patient. So more necessary tests, talking about humidity. So check the accuracy of the relative humidity if your facility does test or does use humidity at all in your incubators. And the humidity should be within plus or minus 10% of what the tester indicates. The air velocity inside the incubator compartment should be measured to make sure it's at or below that 0.35 meters per second that we talked about. Check the oxygen concentration, if it's used, to validate that it's within the acceptable range and that the visual and auditory alarms are appropriately activated. And along with providing oxygen-controlled environments, many incubators also contain built-in SpO2 and monitoring systems and are part of the testing and preventative maintenance for incubators. As we touched on earlier, a lot of incubators do double as weighing scales. So it is important also to measure the scale using a series of calibrated weights to make sure it's accurate. And finally, electrical safety. So most manufacturer performance inspection procedures, they require electrical safety tests, including ground wire resistance and chassis leakage. So keep an electrical safety analyzer. I posted an example of a Fluke Biomedical one, the ESA 612. Keep some kind of electrical safety analyzer close by to help you complete the electrical safety portion of the performance inspection easily. So while some might treat the electrical safety and the other integrated device testing as separate workflows, they're generally treated by the manufacturer and the standards as a single series of work and measurements with just one overall test result file and report. Test automation can help reduce test time and even increase efficiency. So testing each parameter one by one, everything that we talked about, using individual handheld tools can take, a really long time. And service engineers and biomeds and hospitals are extremely busy, and that kind of time just isn't really feasible. So using an analyzer that has built-in test automation, I have a picture up here of the Fluke Biomedical InQ2 analyzer. It's brand new, and using test automation with an analyzer can just dramatically reduce the time taken for a test. So, for example, using the example of the InQ2 on the screen, once an incubator has warmed up, the InQ2 can complete a test in, just 15 minutes with the general testing feature. Its onboard automation will automatically run through the tests in both the standard and customizable test templates. So technicians will simply just need to set up the device and start testing, and then you can walk away and are free to perform other work. So other benefits of using test automation in general to validate the performance and safety of incubators are data traceability, simplified data extraction for reporting, and then reduced human error. We should always archive our test results. So the purpose of testing and producing test results in the first place is to have a continuous stream of data showing all changes in the safety and performance of the incubator year over year. So long-term trending of this statistically relevant information provides the basis for predictive maintenance, like when the next repair is most likely to happen. So the parts, especially those long lead time and costly parts, can be ordered and received just in time for the repair event. So this saves money and increases the amount of time the medical device is available for use. In regard to incubators, a longer stay for the patient is both costly for the family and the hospital, like we talked about earlier in the webinar. So ensuring an incubator is operating properly and can be repaired in a timely fashion is important for all parties involved. The best place to archive test information is in a database or computer maintenance management system, CMMS. In contrast, archiving paper in filing cabinets, genuinely, it rarely results in anyone actually capturing or understanding or even looking at the long-term implications of failures. So finally, choose test equipment that you can depend on for full preventative maintenance. You need to use separate equipment. So some incubators, for example, will have a self-check in them, but you need to use separate equipment because, as specified by regulatory bodies such as the FDA, independent objective evidence for parameters that you measure is required. When choosing your instruments, remember that metrology matters. What I mean by that is, when you go down to the gas station to get a gallon of gas, how do you know that you're really getting a gallon of gas for the price at which it's posted? Well, you know because of metrology. And metrology, it's the science of measurement and that measurement's application, and especially within medical device quality assurance, it matters. It also matters when we consider fair trade, so consistency in the measurements when we buy and sell products. Safety. We depend on measurements for medical, electrical safety and minimum performance standards. Legal requirements. So manufacturers and hospitals have a legal responsibility to keep records to show that medical devices and test instruments used to evaluate them are accurate and traceable. Interoperability. So measurement parameters for medical devices manufactured in Asia should be correlated to the measurements performed in the U.S. Traceability. Interoperability depends on all measurements being traceable to a single reference point. And finally, consistency and quality. So we want to remain consistent and accurate in order to build and test products with quality. So that's why metrology matters, and the test equipment that you use also matters. So the metrology, quality, and accuracy of measurements is important with every test and measurement company, including Fluke Biomedical. So for example, the InQ2 is the best in class. It's an all-in-one tester for preventative maintenance of just not incubators, but also transport incubators and radiant warmers as well. So the InQ2 will allow users to streamline their workflow, increase productivity, save time with features like simultaneous measurement of the parameters that we talked about, real-time results, and pass-fail indicators for really easy troubleshooting, wireless functionality. You can have personalized test sequences and automatic test completion, and then, of course, compliance with global standards. So we're coming up on the end of our webinar, and tying it all together now. The purpose of this webinar today was to understand why a uniform environment is important to the infants inside an incubator, to learn and review the basic functioning of infant incubators and understand the warm-up time, the overshoot, and the concept of STC, or standard temperature condition. Measuring all parameters simultaneously helps us build a full picture of what's going on. So if I, get a call from a nurse and they say, oh, this incubator isn't working. Okay, great. I run up there and do a quick check. Nothing seems to be wrong. They tell me again the incubator's not working. Well, the patients are in there for long term, right? More than just a few minutes, sometimes up to months at a time. So what's going on at hour 3? What's going on at hour 4? How do you do the long-term testing? And how do you know if something's going on with temperature? How do you know that that's not caused by airflow and thus, the air fan, things like that? So measuring all parameters simultaneously will help give you that big picture. We reviewed the importance of testing, the global standards, regulatory requirements, the types of testing, and some test instrumentation that you might need now to consider using for incubator quality assurance and performance testing. And as always, Fluke Biomedical, our main goal is to help you reach the best decisions and provide you with the appropriate test tools to do the work. So at this point, I'd like to hand it over and open it up to any questions that we might have from the audience.
Thank you so much. Great presentation, Ashton. Really, really informative. We got tons of great questions. Here's the first one. Are the requirements for testing infant incubators and transport incubators different?
That's a great question. And the very short answer to that is yes. So the basic parameters will be the same, as in you'll still need to measure temperature at different points, humidity, airflow, oxygen, etc. But when you think about how an incubator and a transport incubator differ, Well, transport incubators are put on the move. They are put in sometimes extreme environments, and they're battery operated a lot of the time. So you need to be sure to follow the preventative maintenance from the manufacturer, their inspection procedure, and or the standards. So the standard for the transport incubator is IEC 60601 2-21. And there, both of the inspections will say the temperature ranges will need to be tested a little bit differently. So the acceptable ranges are a little bit different, etc. So long answer short is yes, they do slightly differ.
Great. Next question. Is an infant incubator a life support device?
That's a great question. And to be completely honest, it truly depends on who you ask. So as for the U.S., we go by the FDA. The FDA is kind of the rule and the law of the land. And the FDA says no, that incubators are not considered life support devices. However, if you consider what a life support device is, which is without the existence of this device, the patient would then undergo unnecessary harm and or death and would not be able to survive. And again, going back to these premature and sick patients, one could very well argue that without the incubator there, then the patient wouldn't be able to survive. So it depends on how you look at it, but according to the FDA, no, incubators are not considered life support devices.
All right, next one. Why is simultaneously testing all parameters at once recommended? What's the difference if I just use handheld instruments to make my measurements, not an analyzer?
That's a really good question, and we touched on this towards the end. So, getting a full picture of what's going on inside the incubator is extremely important. So, what's going on with temperature at the same time as sound being mapped with airflow, because all of these parameters work in conjunction with one another to make the incubator a stable, uniform environment. And the problem with using, just like a handheld test tool for temperature and then another one for airflow is that you're not getting the full picture of what's happening. And also, most of the time, that requires opening a porthole and, putting your hand in there and putting the sensor in, at least one of the sensors, and that disrupts the whole test environment as a whole. So, and the other part of it is using handheld test tools. Like, say, for example, I'm using a handheld test tool to measure the temperature. And if I do want and I need to measure the temperature in the 5 different points of the mattress, yes, the temperature environment of the incubator may be disrupted, but on top of that, it also becomes more time consuming, right? And then again, having to do each parameter that way doesn't give you a full picture of what's happening together as the incubator is functioning.
Okay, here's the next one. Does the Flute test equipment meet or exceed testing requirements for all incubators available for purchase in the U.S.?
Yes, it does. Because all incubators in the U.S. Are manufactured by OEMs that are regulated by the FDA, and remember that all ties back to the standards. So for incubators, transport incubators, and radiant warmers, the IEC 601 standards, it's 2-20, or 2-19, excuse me, 2-20, and 2-21 respectively. So all of Fluke's devices, especially those, like I've got a picture on the screen now of the InQ2. So especially those that are specific for the incubator radiant warmers, that is compliant with all the global standards, yes.
Great. Okay, here comes a good one. I, like most technicians, really like all the test equipment available for testing, but I work at a small hospital which has just a few devices for each type and cannot afford to purchase testers. Is there any way to get some of these testers at a more affordable price?
That's a really great question, because most of us here, or at least I hope so, are all familiar with Fluke Biomedical. And analyzers in general, not just from Fluke, but from all test measurement companies, especially when they're all in one, are more expensive than the handheld ones. And I mean, especially in hospitals where you know it's a smaller one, or the budget for the biomed department either isn't in your hands or it's not very large. It can seem hard to justify the use of this just because of the money aspect. So what's important, and we do have an example of this, and so you know, I have no problem. Reach out to me after the webinar and I can provide you with it. But we do have what's called a return on investment calculator, an ROI calculator. And I think that will really help you. So what it does is it will ask you, you know, how long does it take you to currently test an incubator or radiant warmer with your current, you know, procedure and the tools that you use. Combine that with, you know, the visual checks, combine it with the electrical safety, everything that the manufacturer says and what you're currently doing. How long does that take you? And then there's another portion where it says, okay, well, using this device, with the same things being tested, this is the time difference. And often the time difference is very significant. So, for example, I had someone come to me and ask me this question, and they said, "Oh, we only have, you know, 4 incubators in our hospital." I said, "That's fine." And they said, you know, I asked them how long it took, and we talked about it. We sat down with it, and it turns out that using, you know, for example, the InQ2, one of our incubator analyzers, the time savings was so significant. I mean, it was saving them over an hour for each incubator. And so that's, you know, four hours saved for an incubator, but then you look at the hourly billable rate, which runs between, you know, $65, sometimes up to like around 90, anywhere between there. So you multiply it by that, and that's just 1 year's savings. So you compound that over 2-3 years, and even with very small amount of incubators, just a year, 2-3 years, and the price of an analyzer is completely justified. And if you've got, you know, say 10 or more in your facility, I mean, the savings of both time, so you have time to, you know, set up the device, press test, walk away. You can perform all the other testing for the incubator, your electrical safety, visual checks there, or go do other work. So you're saving time, and you're also saving money for your hospital. And when you talk to, you know, the advisor, or, you know, if the COO is the one that, the CFO is the one that signs off on it, that's what they're really looking for. So it can definitely be justified that way. And again, I mean, anyone is more than welcome to reach out to me through or after the webinar, and I'd be more than willing to chat. Any of us would.
Awesome. Awesome answer. Okay, next one. Is there a plan to offer an oxygen sensor as an option?
I'll have to know what that question is referring to, as you mean as an option from Fluke Biomedical. And if that's the case, yes, we do have one. Earlier in this presentation, I showed a picture. I didn't speak to it because I didn't want to, you know, shove any products just down your throat or anything. Just rather wanted to show you options. But I did show an example of one. It's called the Max O2 analyzer, and that will measure the concentration of oxygen. And that can be used in conjunction with the InQ2 radiant warmer analyzer.
Great. Next question. Does the INCU analyzer have a trade-in value for the INCU2?
Yes, it does. So if you are a user of the first generation InQ, so the predecessor of the InQ2 shown on the screen, that product is being discontinued. And yes, it will be continued to be serviced, no problem. But if you have one, just work with your local sales rep, because we do have a trade-in program to upgrade you from the InQ to the InQ2 and save you a bunch of money while you do it. So, yes.
Okay, thanks for taking it easy on me going INCU. I won't spell out any more words. Okay, I know, next question. I know that we have to measure a 5 points, but if a point is not up to the temperature, what are we able to do to fix this deficiency?
Can you repeat that question just one more time?
Yeah, I'm reading it right up from the attendee. Okay, I know that we have to measure at 5 points, but if a point is not up to the temperature, what are we able to do to fix this deficiency?
You know, I'm not sure that I'm fully understanding what that question's asking. So what I'm going to do with that question is I'll have you send it to me along with the user that sent it, and then I'll connect with whoever sent this question in directly, and that way I can better understand your question and then answer it, correctly.
Great idea. Okay, last question here, everybody. What can you test a temperature sensor? How can you test a temperature sensor?
By temperature sensor, I am assuming that you're talking about the skin temperature sensor from the incubator or radiant warmer. And if that's not the case, again, I'll have these questions reach out to me directly. But so I'm assuming that this question is meaning the skin temperature sensor from the incubator radiant warmer. And how that is tested is a lot of times, people will say that they will, submerge it in a water bath and things like that. And it gets quite complicated. So what the InQ2 does to measure the skin temperature probe is it's got a plug-in with an external heater at the end of it. It's just a small box. And you take the probe from the incubator or the radiant warmer, the manufacturer's probe, and you place it inside of this external heater with the InQ2. And that way you can verify, that the accuracy that the incubator is reading for the sensor is accurate with what's displayed on the device and the external heater.
Okay, we have a host of other questions, but we're going to send those directly to you guys. Ashton, thank you so much. Fantastic job today. Thank you again to today's sponsor, Fluke Biomedical. We will have one lucky attendee today who's going to win a lunch for their entire department. Details are included in the post-webinar survey, which will appear on your screen shortly. You must complete the survey to obtain your certificate of attendance. And if you do not see the email, or the survey, please email us at webinar@mdpublishing.com. Again, thanks to Ashton, thanks to Flute. Great turnout today, and we will see you next webinar Wednesday. Have a great rest of the day.
Thank you.